This section is about using our theorems as justifications with parallel lines. We're going to be using given, conclusions, and reasons in this section, GCR. So the first theorem in your notes is the corresponding angles theorem. Written out, it says if a transversal intersects two parallel lines, that's the hypothesis, then corresponding angles are congruent. The hypothesis is going to go with the given. The given is specific to our drawing. So in our drawing, we have a transversal, line N, and we have given that M and L are parallel. The conclusion is going to go with the then part of the written out statement. So corresponding angles are congruent, and then our congruent angles are going to be specific to this drawing. I chose to write out angle 2 and angle 6. There are lots of other congruent angle pairs in this drawing. I could have said angle 3 and angle 7, angle 1 and angle 5, or angle 4 and angle 8. Those are all corresponding angles in this drawing. So as you're doing GCRs, remember that the if part goes with the given, and the given is specific to your drawing, and the conclusion goes with the then part, and the conclusion is specific to your drawing. The theorem is general, and then your conclusion is based on your particular drawing. The reason is just going to be the name of the theorem every single time. Don't try to make up a reason. Use just the name of the theorem for your reason. Okay, these are some more examples for your notes. Alternate interior angles and alternate exterior angles are going to be congruent. And then there are only two examples that we could use from this drawing. If we're given that M is parallel to L, then we can say 3 and 5 are alternate interior angles, or 4 and 6 are alternate interior angles, and so we know those are congruent. For the alternate exterior angles, we can only say 2 and 8 or 1 and 7 from this drawing. Same side interior angles and same side exterior angles are going to be supplementary, so our conclusion will be that we have supplementary angles. All right, so this is one to try. We're going to look for the reason on these two theorems. If I know that 3 and 5 are congruent, I know that 3 and 5 are alternate interior angles. So our reason is going to be the alternate interior angle theorem. We have parallel lines. That was part of the if of that theorem, and we are concluding that 3 and 5 are congruent for this particular drawing. And then for number 2, I'm looking at angle 1 and angle 8, and these are going to be supplementary angles, and the reason is same side exterior angle theorem. So really a big part of it is being able to name what angle pair you have, same side exterior angle theorem. And so that's going to give you the reason. Notice in all of these, our given is that we have parallel lines, and our conclusion is something about the angles. The converse theorem is going to be a little bit different. For the converse theorems, we are going to be given something about the angles. In this case, corresponding angles are congruent, and our conclusion will be that the lines are parallel. So if we're trying to show that the lines are parallel, we're going to use the converse theorems. The converse theorems are going to justify why the lines are parallel, and the other theorems, the ones that aren't converse, will justify something about the angles. So these are the ones in your notes. If I'm looking at congruent, I'm given that I have congruent angles or supplementary angles, then I can make a conclusion that the lines are parallel. All of these converse ones will end with two lines are parallel. The tricky part is deciding which lines. So here are some to try. This is, I'm looking at knowing something about the angles. I should be able to decide something about the lines. So for example, I did these out of order, but this is number 4. If I know that 10 is supplementary to 13, this is number 4. My conclusion based on that is that, well, the angle pairs, the angles that I'm looking for are both on lines A and B. So my conclusion is going to be that A is parallel to B, and the reason for that is same side interior angles. But because I'm showing from the angle to the lines, this is going to be the converse. So I'm starting with the angle that's a converse of the same side interior angle theorem. And then I think I did number 3 next. Yeah, so I was highlighting that those were the 2 lines that I knew were parallel because 10 and 13 are between those 2 parallel lines. The next one I was looking at 2 and 11. 2 and 11 are on the parallel lines C and D. The transversal is A, and so our conclusion is that C is parallel to D, and our reason is converse because we're showing parallel of alternate exterior angle theorem. And then our last one is about angle 2 and angle 6. Angle 2 and 6 are on the transversal C, and they are on the parallel lines for A and B. They are corresponding angles, so we know that A is parallel to B, and the reason is the converse of the corresponding angle theorem. These are always going to be converse because our given is about the angles and our conclusion is about the lines being parallel. All right, so you're going to try 6 through 14 and then I will go through them, but make sure you try them first. Pay attention to whether you're dealing with the converse or whether you're dealing with the theorem itself. Okay, on this page, pay really close attention to which lines are parallel. Notice where your transversal is for each given problem, and then use that transversal to show which set of lines are parallel. Also notice that number 9 is the only one that ends with the conclusion that you have parallel lines. So if you're given parallel lines, then it's the regular theorem, and if you're given something about angles and your conclusion is parallel lines, then you're using the converse of the theorem. Try these last 4 before you check your answers. All of the ones from 11 through 13 are given something about the lines being parallel, and the conclusion is about the angles. So none of these are converse theorems. And again, really highlight where your transversal is. 1 and 9 are on the transversal A, and so that's corresponding angle theorem. C and D are parallel. 12 and 13 are on the transversal D, so that means A and B are parallel. And then there are lots of different conclusions for number 13. Any one of those would be acceptable because if A and B are parallel, then C and D are both transversals, and any set of same side exterior angles would be okay. Number 14, because 6 and 15 are both on the transversal B, we know that C and D are parallel. Those are alternate exterior angles. All right, thank you. Good luck.